Everyone. For today's lesson, we are going to learn about multiplying and dividing rational expressions. Before we get started for today, what I would like you guys to please do is the following warm-up. I would like you to please practice without using a graphing calculator. Sketch the shape of each graph. We have y is equal to 2 over x, y is equal to 4x plus 1 over x plus 2, y is equal to 5 over x squared plus 9, and y is equal to x squared minus 4 over x squared minus 9. Please take a few moments to try this problem on your own, and then when you have an answer, please restart the video and we will see how well you did. All right, let's go ahead and check this out. Well, first of all, I'm looking for a sketch, so that doesn't mean I'm looking for exact answers. So what I want you guys to notice is that problem number 1 is our inverse variation function. It's our most basic function. The only thing that's different is that our a value is a 2 instead of a 1. So we know that whenever we see just an x in the denominator, our vertical and horizontal asymptotes are always located at x is equal to 0 and y is equal to 0. And because there is no reflection, that means that our graph is going to be two branches that is showing like a positive slope. And they're going to be reflections of each other approaching both of these asymptotes. Next, for number 2, this one is considered a linear over a linear. It still falls into the category of a simple rational function. The difference this time is that we know that our vertical asymptote is going to be located at x equals -2, and our horizontal asymptote is going to be located at y equals 4. And we know that because this is a linear over a linear. So we would anticipate that the graph of this function is going to look something like this, where the graph has been shifted. And we can see that our branches are approaching the asymptotes. For number 3, in this problem, there doesn't exist a vertical asymptote. So that means that we just have a horizontal asymptote. And since the degree of the numerator is different than the degree of the denominator, we know it's located at 0. And whenever there doesn't exist a vertical asymptote, it's going to create a bell-shaped curve, very similar to what you see here. And finally, for number 4, x squared minus 9 will produce two vertical asymptotes, one located at x equals -3 and one located at x equals +3. The degrees of the numerators are the same, the degree of the numerator and the denominator are the same. So therefore, the leading coefficient of the numerator divided by the leading coefficient of the denominator will be our horizontal asymptote. And in this case, it's going to be the number 1. The sketch of this graph, we sometimes call it the three-headed monster, but it's going to have a branch below, a branch below. Sometimes it's above, it just depends on the problem, and a parabola. So if your graph was a little bit different, like you had your parabola pointing down and the branches above, that's fine because this was just supposed to be a sketch. I wasn't looking for exact values. The whole point is that I wanted you guys to recognize when you have a three-headed monster and when you don't. So hopefully this recap was helpful for you. And it's really just important to note that there will always be a horizontal asymptote. The vertical asymptote is the part that's going to be variable. Sometimes you have one, sometimes you don't, sometimes you have two. It just depends on what's going on. All right, let's go ahead and look at our learning targets for today. Our learning targets for today are for you to be able to say, I can multiply, divide, and simplify rational expressions. So we're going to take what we learned in our last lesson about simplifying rational expressions to the next level. Now, rational expressions can be multiplied and divided using the following properties. The multiply rational expressions rule goes like this. The rule for multiplying rational expressions is the same rule for multiplying numerical fractions. Essentially, you're going to multiply the numerators and you'll multiply the denominators. We always multiply straight across. Then we're going to write the new fraction in simplified form. So that's where we're going to use our skills from our last lesson. We're always going to simplify. So we have A over B times C over D. And whenever you multiply fractions, you always multiply straight across. So it's not cross product or anything crazy like this. We multiply straight across. Now you'll end up with AC over BD, but if this fraction can be simplified, make sure you do so. So I'm going to start off by multiplying straight across. I have 5 times 6. I always multiply my numbers. 5 times 6 is 30. X squared times x, that is x to the third power. Remember, there's like a 1 right here. We always add our exponents. And then y to the third. This is all over 2 times 10, which is 20. X, y to the 2, 1, y squared times y is y to the third. Now what we're going to do is we're going to simplify each piece individually. Always put your variables in alphabetical order. It'll help you stay organized vertically. But I'm going to simplify 30 over 20. They're both divisible by 10, so this is going to become 3 halves. X to the third over x. Remember that whenever you divide powers with the same base, you always subtract the exponent. 3 minus 1 is 2, and because there are more x's up top, that x squared is going to go on top. And then y cubed over y cubed, that's the same exact thing. So they are going to actually cancel away, leaving us with our answer of 3x squared over 2. And that's all that you're going to do. You're just going to multiply straight across and then simplify. So let's go ahead and look at example number 1. In example number 1, I'm going to go ahead and multiply straight across. I have 2 times 6, which is 12, x to the third times x, which is x to the fourth. I have a y in there and then a z to the fifth. This is all over 3 times 10, which is 30. I don't have an x, but I do have a y to the fifth and then a z to the fourth. And now I'm going to simplify my numbers and then all of my variables vertically. So 12 and 30 are both divisible by 6. So I'm going to divide both the numerator and the denominator by 6. 12 divided by 6 is 2. 30 divided by 6 is 5. Next, I'm going to have an x to the fourth power because I do not have any other x's to simplify. This is a y to the first over a y to the fifth. 5 minus 1 is 4, and since there are more y's in the denominator, that y to the fourth goes into the denominator. And then I have a z to the fifth over a z to the fourth. 5 minus 4 is 1. There's more z's up top, so that z to the first will stay up top. And that is your simplified form. There's nothing more that I'm looking for. Next, I'm going to go ahead and look at a number 2. In number 2, we're working with bigger numbers, 9 times 32 and 8 times 27. And those values are like a lot bigger. They're bigger than working with 12 and 30. They're way more complicated. So if I were to go like 9 times 32, that's 288. And 8 times 27, that's 216. Nobody works with those numbers. So instead, I want to show you guys another strategy. What I notice here is that 9 and 27 are related to each other. I notice that 32 and 8 are related to each other. So some of you might have learned like crossing out and replacing the numbers with what 9 over 27 is equivalent to, and same with 32 over 8. And that is an absolute valid approach. But I want to show you something that requires a little bit more steps, but still is more visual. And my visual learners appreciate this a lot. So take those numbers, 9 times 32, and just write them as 9 times 32. Then we'll have an x and a y squared. So I'm not truly multiplying them together, but I'm just rearranging their order. And then I know that 9 is related to 27, so I'm going to put 27 first. And then I know that 8 is related to 32, so I'm going to put an 8 there. And then we have the letter y. So I'm lining everything up with what it matches with. So 9 over 27 is 1/3. So I'm going to leave my 3 on the denominator. And 32 over 8 is 4. So I have 4 over 3. The x is going to stay up top. And then I have a y to the second over y to the first. 2 minus 1 is 1. There's more y's up top. So that's where the y goes. And this is simply our answer, 4xy over 3. Please go ahead and try example 3 on your own and have that ready for the next time that I see you. Use whatever approach that you would like to, and then we will compare our answers. So now what we're going to do is we're going to multiply when we have, instead of just expressions that have exponents, What we are now going to do is work with polynomial expressions. So our steps from whenever we are multiplying polynomial expressions is we want to factor both the numerator and the denominator just like we did before. But then we're going to cancel out any factors. So anything that you see that's going to be the same on the numerator and the denominator, feel free to cancel before combining into one single fraction. So after you've divided out your common factors, we are then going to multiply the numerators and multiply the denominators together to create a single fraction. And if there's any more for us to simplify, we will make sure that we do that if necessary, but our simplified answers must be written in complete factored form. And I know that I've talked about this before, but I cannot emphasize it enough. I am going to specifically be looking for factored form. It tends to be easier and less steps if you do that. So let's go ahead and look at example number 4. In example number 4, I have an x minus 4 over x cubed plus 8, and we are sophisticated math students to now recognize that this is a sum of cubes, so we're going to use the SOPs method. So that's going to be an x plus 2. Remember, we're taking the cube root of our first term plus the cube root of our second term. And then we're going to write square opposite product square, x squared. Opposite of a plus is a minus. 2 times x is 2x. And then 2 squared is 4. This is multiplied by x squared minus 2x plus 4, which look at there, x squared minus 2x plus 4. So I'm just going to write that out again. And I'm just going to make it over 1. And we can clearly see what we are going to be canceling. We're going to be canceling those x squared minus 2x plus 4. And remember that trinomial is never factorable. So always remember that. This is never factorable. So our answer is simply going to be x minus 4 over x plus 2 times 1, which is simply x plus 2. Now, some people might say, Miss Olivero, can't I cancel out the x's and make this negative 4 over 2, which is negative 2? And the answer is no. The main operation in both the numerator and the denominator has to be multiplication in order for you guys to just simplify or cancel away. And we don't have this in example 4. Let's look at example 5. We're going to factor the numerator. I can see that 3x squared and 3x have in common a 3x, with the leftovers being x minus 1. This is all over 2 parentheses, splitting apart the x squared into an x and an x. I asked myself what 2 numbers multiply together to equal negative 5 and together add to equal 4, and that is a plus 5 and a minus 1, times 2 parentheses, splitting apart the x squared into an x and an x, and I asked myself what 2 numbers multiply together to equal negative 20 and together add to equal 1, and that is going to be a plus 5 and a minus 4. This is all over 3x, and anything that you see in the numerator and the denominator that's the same immediately gets canceled out. So the 3's will go away, the x's will go away, the x minus 1's will go away, the x plus 5's will go away, and all we are left with is an x minus 4. That's all that we are left with, so therefore our answer is simply x minus 4. Hopefully you guys have those sound effects going, because there's nothing cooler than just start canceling. Just like that. All right, let's go ahead and look at example 6. Example 6, I'm going to, I always want my leading coefficient to be positive. I know I've talked about that a lot, but if we can make sure that leading coefficient is positive, make sure you factor out a negative. So I'm going to start off by factoring out a negative 5x. Leftovers is going to be an x minus 4. This is all over, factoring out an x, I'm left with x minus 1, times, I'm going to split this trinomial apart into 2 parentheses, splitting apart the x squared into an x and an x, and asking myself what 2 numbers multiply together to equal negative 4, and together add to equal 3, and that is a plus 4 and a minus 1. This is all over x squared minus 16. We all know that it's dots, difference of 2 squares, so that's going to be an x plus 4 times an x minus 4. So now what we're going to do is cancel away anything that you see that's the same on the top and the bottom. So I do not see a negative 5, so I'm going to identify that, but I do see x's. So I'm going to cancel away the x. I see an x minus 4 in the numerator and the denominator. I see an x plus 4 in the numerator and denominator, and an x minus 1 in the numerator and denominator. So it looks like negative 5 is our answer. There's nothing more to write down. All right, let's go ahead and flip the page. And now we are going to talk about dividing rational expressions. So we've talked about dividing fractions before. There's a little phrase, flip the second guy and multiply. And that's exactly what we're going to do here. So to divide one rational expression by another, you must multiply the first fraction. We're going to multiply the first radical expression by the reciprocal, which is the flip of the second rational expression. So the phrase goes, you flip the second guy and you multiply. So in this problem, if you have A over B divided by C over D, we're going to write the reciprocal of that second fraction, A over B times D over C. And then that AD, we multiply straight across, and we end up with AD over BC. If it can be simplified, make sure that you do so. Same thing with right here. We have 2/5 divided by 7/3. I take that 2/5 and I multiply it by the reciprocal of 7/3, which is 3/7. We end up with 6 over 35, which is our answer. It cannot be simplified any further. Same thing with over here. I had 7 over x plus 1 divided by x plus 2 over 2x minus 3. I'm writing the reciprocal of that second fraction and multiplying. And then from there, we're going to multiply straight across. And anytime you see an addition or subtraction, make sure you put it into parentheses. So let's go ahead and look at example number 7. In example number 7, I'm going to rewrite my first fraction again. That is 3x to the third power y all over 2. And I'm going to change this to y to the third z so that it's in alphabetical order, times the reciprocal of my second fraction, which is 10y to the fifth over 6xz to the fifth. Now you can use that trick that I showed you guys before where you can rearrange, or you can simply multiply straight across. When I multiply straight across, this is going to become 30x to the third y to the, it looks like to the 6th power. This is all over 2 times 6 is 12. I have an x, a y to the third, and then a z to the, what looks like the 6th power. So now I'm going to simplify my numbers. 30 over 12 are both divisible by 6. 30 divided by 6 is 5. 12 divided by 6 is 2. I have an x to the third over an x to the first. 3 minus 1 is 2. There's more x's up top, so x squared goes on top. I have a y to the 6th over a y to the third. 6 minus 3 is 3. There's more y's up top, so y to the third goes up on top. And then I have a z to the 6th in the denominator. So there is nothing more for me to simplify here. Next, I'm going to look at an example number 8. In example number 8, I'm going to rewrite this as 7y squared over 8x squared times the reciprocal. So I have 40x over 21y. For this problem, I'm going to, instead of multiplying straight across, I'm going to look for relationships. And I know that 7 is related to 21 and 40 is related to 8. So when I rewrite this, I'm going to rewrite it as 7 times 40, x, and then y squared. This is all over 21 times 8, and then x squared y. So now I know that 7 over 21, that's 1/3. 40 over 8, that is 5. X to the first over x squared will leave me an x in the denominator. 2 minus 1 is 1. There's more x's in the denominator, so that's where the x to the first goes. And 2 minus 1 is 1, but there's more y's up top, so that's where the y goes. Y goes up top. 5y over 3x is our answer. Finally, with example number 9, we're going to factor, and I'm going to factor the numerator of 3x squared plus 13 minus 10 into a 3x and an x. And I'm looking at those factors of 3, which I know are 1 and 3, and the factors of 10, which we typically use 5 and 2, and I have to somehow come up with a 13. So a positive 13. I know that 3 times 5 is 15, and if it was positive, and 2 times 1 is 2, and it was negative, I would end up with a positive 13. 15 minus 2 is 13. So I'm pretty sure this is my factorization. This is all over 6x squared. And then technically, this 3x squared minus 2x is over 1. So when I write the reciprocal of that second fraction, this is going to be 1 over x times 3x minus 2. Now I'm going to cancel away anything that's the same in the numerator and the denominator, and I notice that I only see the 3x minus 2's that's the same. So therefore, my final answer is simply going to be x plus 5 over 6x squared times x to the first is 6x cubed, and it looks like that's it. There's nothing left in the denominator. This is simply our answer. The remaining problems are a team and solo question that we are going to complete the next time that I see you guys in class. So that makes this the end of this lesson. If you guys have any questions over anything that I showed you, please feel free to email me. Otherwise, I hope you have a wonderful day.